Hello, everybody. We've got another visual pattern challenge for you. Here is step one, here is step two, and here is step three of our pattern. And you can see it looks like some squares and triangles in each step. And we're not actually supposed to count the squares in the triangle. We're supposed to count the number of line segments. So the challenge here would be for you to predict how many line segments are going to be in step four. If you can do that, maybe you can figure out how many are in step 43, and maybe you can write an equation along the way that you could use to predict the number of line segments in any step at all. So that's the challenge. If you'd like to accept it, pause the video and see how it goes. All right, so we've got a square and a triangle on this first one, and then it looks like two squares and a triangle. So if I were just going to predict based on squares and triangles what was in step four, it'd be 4 squares and a triangle, or in step 43, 43 squares and a triangle, but we need to count line segments. So let's look what happens with the number of line segments in every step. So in this first step, I'm just going to mark these off as I count them. So 1, 2, 3, 4 to make the square, and then 2 more, 5, 6 to make the triangle. And then it looks like that part is here from the first step, and what we've added to make this additional square in the end is 1, 2, 3 more segments. So it looks like 6 in the first step, then it goes up by 3, and then, yeah, same thing. Here is the step 2, and then we have to add this one, and this one. So if I were going to predict step 4, we'd have another square added to the end, so 1 more, and then the triangle there. And so how many would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, looks like. So I think my prediction for step 4 is 15 line segments. But let's go ahead and analyze these numbers carefully. So I'll make a chart with the step number and the number of segments. In step 1, I counted 6, and in step 2, we're adding 3 more, so that's 9. In step 3, we're adding 3 more to that, so that's 12. And in step 4, we're predicting 15. Once we've got our numbers listed out nicely like this, we're going to find the difference in each step. So 9 minus 6, that's 3. 12 minus 9, that's 3. 15 minus 12, that's 3. And that should make sense. We were adding 3 to every step, so the difference between each step should be 3. When the differences are all the same number, you have a linear pattern. So we can use this equation, y equals mx plus b, to model that pattern. The slope, which goes here where the m is going to be the rate of change of this pattern. So y equals 3x, and then plus something. This b we're going to use to adjust to make sure the pattern works out with what's actually there. So y is going to stand for the number of segments. X is going to stand for the step number. So if we were to use this equation right now as it is, we would say y equals 3 times, and in step 1, we'd say 1 for x. Now, calculating that, 3 times 1 is 3, but we've got 6 here, so that's 3 short, so we'd need to add 3 more. So let's put that in our equation. Now, our equation is y equals 3x plus 3. Let's see if that works with step 2. So y equals 3 times 2 plus 3. So that would be 6. 3 times 2 is 6, plus 3 is 9. Yeah, that's how many you have in step 2. Let's try with step 3. Y equals 3 times step 3 plus 3. A lot of 3's there. 3 times 3 is 9, plus 3 is 12. Yeah, that's how many we have in step 3. So this equation looks good. Y equals 3x plus 3. Once we've got an equation, we can use that to calculate the number of segments in step 43. So y equals 3 times step 43 plus 3. And 3 times 43, well, 3 times 40 would be 120. 3 times 3 is 9, so it's 129. Plus 3 more would be 132 line segments in step number 43. Well, how did that go for you? Did you see that it was a linear pattern? Did you get 15 for step 4? Did you get 132 for step 43? Let me know. Thanks, everybody.